In this video, I want to show you how we can use sum to product formulas to prove identities. Here we have a list of sum to product formulas. We want to prove this identity using these formulas. For numerator of this expression, cosine of 3x plus cosine of x, we can use this identity. Cosine of any angle alpha plus cosine of beta is equal to 2 cosine of sum of the angles over 2 times cosine of the difference of the angles over 2. By using this identity, for the numerator, we have 2 cosine of sum of these two angles. 3x plus x is 4x. But when you add the two angles, you have to divide it by 2. 3x plus x is 4x. 4x divided by 2 is 2x. So 2 cosine of 2x times by cosine of alpha minus beta. Alpha is 3x, beta is x. 3x minus x is 2x. 2x divided by 2 is x. So numerator can be written as 2 cosine of 2x cosine of x. Now we write the denominator in the product form. Sine of 3x minus sine of x. For the denominator, we use this formula. Sine of alpha minus sine of beta is 2 sine of alpha minus beta over 2 cosine of alpha plus beta over 2. By using this formula, we have 2 sine of alpha minus beta. 3x minus x is 2x. 2x divided by 2 is x. So we have 2 sine of x cosine of sum of the angles over 2. 3x plus x is 4x. 4x divided by 2 is 2x. Now look at the numerator and denominator. We can see that the cosine 2x from numerator with cosine 2x from denominator cancels. 2 from numerator with 2 from denominator cancel each other. And then we have cosine x over sine x. So this equals cosine x over sine x. From quotient identities, cosine over sine is cotangent of x. So we use sum to product formulas. We write this expression in this form. We simplify the expression, and with the aim of quotient identities, we get to cotangent, which is the other side. So we prove this identity using sum to product formulas. Let me show you another example. We want to prove that sine of 4 theta plus sine of 2 theta over cosine of 4 theta plus cosine of 2 theta is equal to tangent of 3 theta. For numerator, we need to use the formula that is in the form of sine of alpha plus sine of beta. And the reason that we use this identity, this relation, and we write this in the product form is that these two angles are completely different angles. It's like an angle alpha and an angle beta. And it's not easy to write them in the form of each other. So that's the reason we think to using sum to product formula for numerator and also for the denominator. Let me remind you, sine of alpha plus sine of beta is 2 sine of sum of the angles over 2 cosine of the difference angles over 2. So numerator is 2 sine of sum of the angles. 4 theta plus 2 theta is 6 theta. Divided by 2 would be 3 theta. Times by cosine of alpha minus beta. This is alpha and this is beta. Alpha minus beta divided by 2. 4 theta minus 2 theta is 2 theta. Divided by 2 would be theta. This is for numerator. For denominator, we have to use the formula cosine of alpha plus cosine of beta. Let me show you the formula for cosine of alpha plus cosine of beta. Based on the formula that here we have, cosine of alpha plus cosine of beta is 2 cosine of sum of the angles over 2 cosine of the difference of the angles over 2. So we have 2 cosine of sum of the angles. 4 theta plus 2 theta is 6 theta divided by 2 would be 3 theta. Times by cosine of the difference. 4 theta minus 2 theta is 2 theta divided by 2 would be theta. Simplify this. 2 with 2 cancels, cosine theta with cosine theta cancels, and we have sine of 3 theta over cosine of 3 theta. Sine over cosine, based on the quotient identity, is tangent of 3 theta. And we proved this identity here with the aim of sum to product formulas. Now look at this example. Sine of alpha plus sine of beta over cosine of alpha plus cosine of beta is tangent of alpha plus beta over 2. For numerator again, we use the sum to product formula. Sine of alpha plus sine of beta based on the sum to product formula is 2 sine of sum of the angles alpha plus beta over 2 cosine of the difference of the angles alpha minus beta over 2. This is for numerator based on the formulas. For denominator, cosine of alpha plus cosine of beta is 2 cosine of sum of the angles over 2 cosine of the difference of the angles over 2. If we simplify this, we can see that the 2 from numerator with 2 from denominator cancel. This cosine with this cosine cancels. What remains? From numerator we have sine of alpha plus beta over 2. In denominator we have cosine of alpha plus beta over 2. Sine over cosine is tangent. So this is tangent of alpha plus beta over 2. From quotient identities, sine of alpha plus beta over 2 over cosine of alpha plus beta over 2 is tangent of alpha plus beta over 2. And this completes the proof of this identity. Now look at this example. This is a little more advanced example. It is a little harder. In numerator we have 3 terms, in denominator we have 3 terms, and we want to show that this complicated fraction here equals tangent of 3x. If you attention, if we ignore these terms, we have sine of 3x over cosine of 3x in the middle. The middle term is exactly tangent of 3x. The other thing that it's good to notice is that x plus 5x over 2, basically sum of these two angles over 2 is exactly 3x. So here, if we want to use sum to product formulas, it's not a good idea to consider these two as 2 terms and use sum to product formulas for these two. It's good to consider this term and the last term as 2 terms and then use sum to product for these two. The reason is that x plus 5x divided by 2 is exactly 3x. So here, first we rewrite this in the form of sine of x plus sine of 5x, and we write sine of 3x as the last term over cosine of x plus cosine of 5x plus cosine of 3x first. Now we use sum to product formula for sine of x plus sine of 5x. If you remember, this equals 2 sine of sum of the angles over 2. X plus 5x is 6x, divided by 2 is 3x, times by cosine of the difference of these angles over 2. X minus 5x over 2 would be negative 4x over 2, and this equals negative 2x. So we have cosine of negative 2x here plus sine of 3x. This is for numerator. Now let's do same thing for the denominator. We want to write these two terms. We want to write this in the form of the product, sum to product, cosine of x plus cosine of 5x. This equals to 2 cosine of sum of the angles divided by 2. X plus 5x is 6x divided by 2, which will be 3x, times by cosine of the difference of the angles over 2. X minus 5x divided by 2 again would be negative 2x, plus cosine of 3x. Now if you pay attention, in numerator of this fraction, we can factor sine of 3x. And then we have 2 cosine of negative 2x plus 1. And in denominator, if we factor cosine of 3x from this term and this term, then we have 2 cosine of negative 2x plus 1. Now look at the brackets. You can see that this bracket here is exactly the same as this bracket. So this cancels with this. But what remains from this? Then we have sine of 3x over cosine of 3x. But we know that sine over cosine is tangent. So this equals tangent of 3x, which is the other side of the identity. So we prove this identity with using sum to product formulas. Before I finish this video, let me tell you something about this, about cosine of negative 2x. Cosine is even function. But what this means? When a function is even, it means that for that function, negative of x is the same as x. Because cosine is even, so this means that cosine of negative x is the same as cosine of x, or cosine of negative 2x is equal to cosine of 2x. So here, if you want, you can substitute this with cosine of 2x, because cosine of negative 2x is the same as cosine of 2x. But here, because we don't need to do this substitution, we don't need to write cosine of negative 2x, cosine of 2x. Without that also we can simplify the expression, so we don't need to know this rule for cosine. But it's good to know this in general, that cosine is even function. And attention, not all the trigonometric functions are even. Cosine is even, but sine, tangent, cotangent, these are odd functions. So sine, for example, is odd. What this means, when a function is odd, it means that if we have a negative, then we cannot ignore it like cosine. For cosine negative we can ignore, but for sine, if we have a negative for x, you should write it as negative sine of x. You can bring the negative out and you can write it in this form. Also for tangent and cotangent, they are odd. So tangent of negative x is negative tangent of x. I hope by watching this video, you have learned how to use sum to product formulas to simplify expressions and how to prove identities. If you like this video, please subscribe in my channel and see you in the next videos.